All right. Good morning, good evening, or, well, good night in my case, wherever around the world you are. Heini, how are you doing?
I am doing very well. Nighttime here as well, as you can tell. It's a bit dark.
Yeah, but our audience is all around the world. Fantastic audience, in my opinion. It's been a while since I've seen you.
Yeah, it's been a while, but nice to be back here with you. How are you doing today?
I'm very fine, thank you. I'm super excited about today's topic, actually. It's one of my favorite topics, in all fairness, because it's about Cosmos-db, right?
I thought you were going to say indexing.
It is about indexing. That is actually our topic today. And again, it's so great to welcome everyone and tell them welcome to our fantastic Microsoft Learn Live TV session today, part of the Cosmos-db series and part of getting people certified. And today's topic is indeed going to be on defining indexes in Azure Cosmos-db SQL API. Heini, I know for a fact that we have a lot of people who are completely new to our series. So why don't you introduce yourself?
Yes. So hello, everyone. I'm Heini Ilmarinen. I am joining this call today from Finland. And so, yes, it's nighttime here already. And I work as a DevOps consultant for a company called Polar Squad here in Finland. And I'm also a data platform MVP as well. So really, Cosmos-db combines two of my favorite topics, DevOps things and data things. So a perfect
Brilliant
thing. Yeah.
Brilliant. Thank you for doing that. And my name is Alex Mang for short. I am streaming in from Romania right now. And I am what Microsoft calls a regional director, as well as a most valuable professional. My work category is Azure, not data platform. But I always thought of Cosmos-db as an Azure product. I don't know, they're placing it in the data platform and work category, but in all fairness, I still find it to be born and bred in Azure. So it's pretty much a cloud native product to me, as cloud native as it can get.
That is so true. Completely agreed.
Thank you so much for introducing yourself. And I do want to take this opportunity of actually introducing our fantastic moderator today, who is actually Hasan Savran. We had him as a moderator several times, but we also had him as a host. And I do say hi to him and also to the large group of people, program managers, principal program managers, producers, and everyone else who put such a great effort of making this series actually happen. Now, as I've said previously, and as Heini has mentioned as well, today's topic is going to be on defining indexes in Azure Cosmos-db SQL API. And in all fairness, I do want to let the audience know that they go at any point in time after the session, after this seminar, after this webinar, they can always go to Microsoft Learn and get their hands dirty and wolf the entire module and learn indexes at their own pace. But I would not recommend that you do this while we're streaming, because we're going to take questions. So this is your opportunity. This is live. This is like just like live TV. This is your opportunity to get your questions answered. Hasan will take care of them, and we're also going to pick some fantastic questions, read them out loud, or paraphrase them to the extent that we can, and make sure to get them answered. And of course, if we cannot answer them, we'll do our best to take them offline. Heini, you have your Twitter handle right there. So do I, right next to our names, so people can actually follow us or discuss these topics further on Twitter. Heini, I have a question for you.
Yeah, what's the question?
Did you get certified yet?
I haven't gotten my reply yet. I did the test in beta, and so I'm still waiting.
You're still waiting for that. I still believe that actually the exam is still in beta. So until it comes out of the beta phase and it's going to be fully generally available, you won't get a reply back. I'm sorry for you.
Yeah, I have to keep waiting.
Yeah, you have to keep waiting.
Yeah, but the good thing is that after having gotten to be part of this series and really dive deep into these topics, even I feel like now I would be more ready to take the exam. So really, these sessions are really the perfect way to prepare for the exam as well.
I know, right? I was planning on taking the exam somewhere around this time, honestly. But I've gotten to learn so much out of this series, because I almost felt like this is a 15-episode series. We're still going through the month of March and as well as April. So why not wait until the end? And then I'm going to be fully prepared to take the exam.
Exactly.
Of course, jokes aside, I do encourage people, even if it is in the beta phase, to take the exam. Heini, do you want to explain us what a beta exam is and what it's different from besides the fact that you're not getting the result? Not in the spot, at least.
So the beta exam is really the opportunity for the exam makers to get feedback on those questions. So one aspect is, of course, you don't get the results right away because it hasn't been polished to the very end. The other aspect is that they, of course, then highly ask you to kind of give feedback also on any questions that are off or need tweaking or are unclear or anything like that. You get the opportunity to really participate in making that exam as good as possible. And I also believe in the exam phase, beta phase, you get a little more questions than you would get in the regular exam phase as well, because there's some kind of tweaking still going on.
You absolutely do. And I'm going to put my trainer hat on right now, and I'm going to encourage people, if they feel confident without actually taking the extra steps of preparing for another exam, to go into the beta phase, because you don't have any preparation materials like you normally would for other exams. If they feel ready because they've been using the technology for a while, to take the beta exam, not only because it's on a high discount, but as well you get the opportunity to offer feedback on those questions. And that's one of the reasons for why you, Heini, didn't get your answer on the spot. Microsoft is actually collecting all the feedback. Some of these questions might not be relevant. Some of them might not be realistic to the real world scenario. Some of them might be a bit far-fetched, and they're just going to pull out the questions. They're going to have them rephrased, and therefore your score, you get a very good chance of passing the exam, particularly because you're offering feedback and you're making the exam overall better, right?
Exactly.
I really do encourage that.
Yeah. And I have to say that I really liked this exam. It's so focused in one area. Of course, there's areas where it's checking like how do you integrate Cosmos-DB with other services in Azure, but it's so focused on Cosmos-DB that it's kind of also easier to prepare to, even without preparation material. You kind of know what the scope is. So in that sense, it's kind of easier, but also it, of course, goes deeper than maybe some other exams.
I think this is my kind of an exam then.
Yeah.
I remember some exams
like
which were like all over the place, where you have had to learn so many different technologies, including non-Microsoft, but Microsoft-centric technologies nonetheless, from third-party vendors and whatnot. They were still part of the exam. And I was like scratching my head, coming to think about when do I need Ansible and Terraform and Chef and Puppet and ARM in the same project? I don't. And yet I was questioned on all of them. Good. Let's actually focus on our topic today, because we have some fun learning objectives ahead. Our learning objectives today are actually a twofold. On one end, we're going to learn about what an index is, how indexing policy works, as well as we're going to identify the indexing policy data types in Azure Cosmos DB SQL API. And I do want to stress this out. I do want to let everyone know that this is going to be a fully interactive session. So make sure that you go to the chat window, whether you're on Twitch or YouTube or MS Learn TV or wherever you are. Use the chat window, say hi, tell us where you're from. We're more than happy to know where people are streaming from, whether they have morning or night out the window. I'd love to learn that and know more about our audience. Good. So let's get things going. I'm really excited for this topic today. As I've said, this is one of my favorite topics. So if people have questions, I'll be more than happy to hear your questions. By default, as you know, Heini, every single Azure Cosmos DB account and every single container automatically indexes everything. What does that even mean, that they index everything? Because the mindset is a bit different from SQL, isn't it?
It is, because if you think about the SQL world, there you have to specifically create indexes where you need them. Whereas here it's like, well, actually, you have everything on from the get-go. And now what we're going to be going through in this particular module is really looking at how do you configure this in different ways, and what are the ways in which you define that policy, and what kind of data types it supports. And then also we're going to talk about what are the effects of these indexes that we create.
Absolutely. You've mentioned the SQL world, and all of a sudden I've got flashbacks of the clustered indexes, non-clustered indexes, the column store indexes and whatnot. And yes, you do have to create them specifically. And if you don't create them, you pretty much shoot yourself in the foot in the relational world, because everything's going to be on a heap rather than being on a B tree. So you have to do a table scan of all your data. Things are very different when it comes to Cosmos DB. They still call it SQL API, but in all fairness, it's completely irrelevant. The entire thing that you have learned about SQL and how indexes work there is going to be completely irrelevant. So over here, we have an interesting scenario. As I've said, every container has this built-in policy, right? What this thing does is that it determines for each item that it should be indexed. So by default, the policy dictates that every single create, every single update, every single delete operation on any document should always update the index. And that index should include all the properties on all the items. And that's quite interesting because this intelligent, well, sometimes it's not really that intelligent, so let's not overmarket this thing. The intelligent default, nonetheless, is going to be excellent at start of many different solutions. As you get, and well, you're going to write more queries, you're going to become more predictable, and the performance overall is going to be predictable without having you to get your hands dirty with indexing or tuning the index. So for you, Heini, and for your customers, does the default work most of the times, or do you have to tune it a bit?
I would say that in the long run, you'll have to tune it at some point in most cases. Like in the beginning, it's probably the case that we leave the default policy alone and just get started. But then after kind of getting, because I'm often in the picture already in the development phase when the product isn't necessarily already published yet. So in the beginning, it makes sense to just have the default policy in place. And then once we actually know what are the needs for indexing, then we can define that policy and adjust it according to the needs.
But isn't it funny when you come to think about customers working with Cosmos-DB that, I don't know about you, but I've had customers who have been using Cosmos-DB for a while. And after a few months, when I start to tell them about decreasing the RU consumption on the writes they're doing by changing the indexes, because that's many times one of the problems that they come across. And I tell them about indexes, and they're like, yeah, I've seen this index policy somewhere in the portal, but I'm not really sure what that meant because this is no SQL.
Exactly.
And it's like, well, let's go back to the drawing board. So here is actually an interesting example, Heini. And if we're going to review it real quick, what we'll see here is a JSON document on the left side. Let me actually zoom in a bit. So in this JSON document, we have a supposed product named Touring 1000 Blue. And then we have a bunch of a bunch of tags for this bike. The tags all have a key value pair, and the key is always name, and then the value is whatever we're going to tag against. So bike, touring, and blue. And you should always pay attention to the number of things in the tags array. Why do I say that? Well, if we are to represent this JSON as a tree of sorts, and obviously this is just a visual representation of sorts so that it makes more sense. Let me zoom in here on the right side of the tag. We're going to actually see that the object is represented as a tree, and the representation would always include like a traversal path for both the name property and its value. Like we have the Touring 1000 Blue value right there for the name, right? That's the property that we are tagging against. So the tree always contains, in this case, also 3 traversal paths for the 3 objects in the tags array, each with a leaf node for their name properties and respective values. This means that the name, and the name again of bike, touring, and blue are going to be leaves in this tree. So whenever I'm going to query, for instance, for some data where I want to query where tag name equals blue, I know where to get to, because those ones, 0, 1, and 2, they're like indices in the array. But the thing that they don't tell you in this representation is that for each one of these values, there's like the link to the data itself, right? And the link obviously can increase the more data you have on a particular property of that value. If we are thinking as a counterpoint, here's another JSON representing another product, obviously part of the same container. In this case, the product is named Mountain 400W Silver, and it only contains 2 tags, bike and silver. So the object is also unique in that it includes a SKU property with a value of BK yada, 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 something. So the representational tree that we get here for this document is actually going to be a bit different, because now we have the additional SKU, which we didn't have previously, this one right here, and the number of tags is going to be less. But the hierarchical structure that we're getting, obviously the depth of the structure is going to be the same. Now, you know, Heini, what my customers always struggle with?
What is it?
It is the fact that even Microsoft, when they talk about indexes, they always say it to plural. But in all fairness, in reality, in Cosmos-DB, there's a single index per container. So even though you might create a lot of different policies and whatnot, there's a single index. So if we are to properly understand the index, if we are to conceptualize our containers index, we kind of tend to think as the index as the union of all the trees for each item in the container. And it obviously becomes very, very complex. But altogether, this creates what is technically referred to as the inverted index, which gives the database engine something super fast and efficient to traverse when they're performing a query operation, right? So each node in this tree has a metadata which indicates which item in the index would match a specific node.
Or something silver.
Something silver. So you want me to search for a product where the name probably contains something silver, right? So I would start from here, and this is the root that contains all the documents, document ID 1 and ID 2, for instance, right? And I'm searching for on the name property. So I know the in name would be part of my tree. This is what I'm going to query against. All products so far have a name property, but then I want to search where the name equals something like silver. So only this product contains something like silver, and the 2 indicates that this is the second item that I would have to return. And this is the way the inverted index works. You query the values, and the values tell you the link towards the documents that you're trying to resolve back. And similarly, if you were, for example, to ask me about a product where the SKU equals BKM38S-38, whatever that is, I honestly have no idea. Instead of traversing through each item individually, the search engine just traverses the inverted index. For this query, if we are to walk through the same scenario, you start from the top, all the items there match, like 1 and 2. I know this is a small font, so let me zoom in a bit. And then you're searching for the SKU property, yet only a single product has a SKU property. We could potentially even stop here. That's an optimization that the engine has. And then if we want to validate the product, then you could even go further and say, get me the products where the value of SKU equals BK-M386-38, because this is an equality comparison, right? That's what we're searching for. So this would only be the second item. Yet again, the silver product, Mountain 400W. What about that?
Oh, how did that happen?
How did that happen?
I don't know. So here we have another example where we are instead then searching via the name. And again, we just need to then traverse along that one specific route. So we first go to the name, and then we check under the name for this Turing 1000 blue. And we can only find that it is item 1 that is in there. So very similar than the previous example.
Yeah, and in all fairness, these are simple examples because we want to illustrate how the overall concepts of indexing work. And they're definitely different, especially if you're familiar to clustered indexes and non-clustered indexes. And if you're familiar to including some additional tables within an index that you'd use in SQL Server and the SQL engines like Azure SQL Database and whatever have you. So how do you actually define these indexes, Heini, in Cosmos DB? Because I bet you don't write some sort of a special script with create index, yada, yada, yada. You do it in a different way, right?
No, we actually have a specific indexing policy. And that is what we're going to be looking at next. And this is really what defines how this index is created then. So as we already went through, all the data in all the containers is indexed by default. And also, as Alex mentioned, whenever we do any kind of CRUD operation, this index is updated. So really, it is kind of building out that union of those trees that we were looking at in the previous slide, actually. So you can think that it's always building out that based on whatever create, update, or delete we do there, either removing some part or adding some part and so on. Or even adding just the item of like, here is item 3, if we were to add a third item in there. And so all properties for every item are automatically indexed. So pretty much it's all the paths that are in our document. And then if we have strings or numbers, there is something called range indexes that are in use. What do these, Alex, really mean?
Well, these, you mean the range indexes?
Yes.
Good question. So whenever you create an index, you can create an index on something that starts from and then towards, right? And that's the range that you're referring to. And whenever you're trying to find a number, for instance, or a string, that's easy to do because things are going to be alphabetically ordered, for instance, and then starting from A up to D, and then from E up to G, and so on and so forth. That would be a range index that you'd create. Does that answer the question?
Yeah, definitely. Perfect.
Cool.
All right.
So here is something that it has always bugged me a bit, which is the so-called default index in JSON, which obviously is represented in JSON because this is the way you would see it in the Azure portal, in all fairness. And it's the default. And even though it's the default, it looks ugly, in my opinion, really.
It does.
Because what they do is that they create an automatic index, which is going to be of type indexing mode consistent. And then they specify the included paths to be, slash asterisk, and the excluded path, double quotes, slash, backslash, double quotes, underscore, e tag, yada, yada. That's just ugly, purely ugly. But
Yes.
it is the default. And even though it's ugly, it's quite simple. What it does, again, is that it kind of works for pretty much everyone and everywhere, because it indexes everything. Like every single property in every single document is always going to be indexed. And what this means is that the moment you're adding some data in your container, the data is already indexed, implying that you can query in a NoSQL technology. You can query on the values that you have on the properties, irrelevant, even if the data in the container doesn't have the same schema. And that's something for people to think about. If you don't have in a container documents which are of the same schema, no problem. You can still have everything indexed just nicely, and everything will work as expected.
Yeah. It is kind of a bit mind-boggling to think about that you have JSON documents in there that are massively different in format, but still they're both or all indexed.
Yeah, absolutely. Now that indexing mode can be a bit tricky for people to understand. And I think, Heini, maybe you want to cover this one, but there are two primary indexing mode options, right?
Yeah. So really, we have the consistent one, and sorry.
No worries.
I got a bit tripped up here with my words and reading this on my little screen here. So actually, how we start here is that if we're doing like a massive bulk operation, whether it's create or update or delete or anything like that, it might be good to have, for example, the indexing off at that time. But a kind of a regular indexing mode that we would be using most of the time is the consistent indexing mode.
Absolutely. This consistent indexing mode is one that updates the index synchronously as you perform some individual operations that would modify an item. Obviously, this refers to create, update, delete, cut. And this indexing mode will be the standard choice for most containers to ensure that the index is updated as items do change. There's another one, which is none, which completely disables the indexing on a container. This indexing mode, in my opinion, I rarely ever see it utilized. It's more scenario-specific mode where the index on the operation is either unnecessary or could simply impact the overall solution performance.
Yeah,
there are some scenarios which benefit from none. Like a bulk operation to create, update, or delete multiple documents may benefit from disabling the index during the bulk execution period. But again, even when you have a bulk execution, after that completes, I'd still recommend my customers to change the indexing mode back to consistent. Because at some point, I mean, the reason for having the data in Cosmos-DB and not the data lake, for instance, is to query it. Right.
Yeah,
so
exactly.
Not having an index doesn't make sense in Cosmos-DB from that perspective.
And it is exactly that index that can make also those specific queries that we use much faster.
Totally, because if you're trying to get data or documents where you're querying for a particular property, you obviously need those indexes, because otherwise you're going to do table scans. There's no tables here though. The only thing I can think of, and this is a production scenario that we actually have utilized with, was that we would never query the data in the container, specifically in the container that we created only for a single purpose, but we would determine the data by using single point operations. So we would always query the data by the identifier. But that also implies that you're treating Cosmos DB as a key value pair. So your table API might be a better API than the SQL API from that perspective. But if you're still on the SQL API for other reasons, then the solutions that would use containers as a pure key value pair store would benefit from this point read operations, where you retrieve based on the partition key and the identifier, the single item, and you don't care about indexes at all. These containers don't benefit from having secondary indexes.
Yeah, that's good to highlight. Perfect.
Now, in that JSON document people saw previously, there was an include and an exclude. What do those do?
Yeah. So they might be a little self-explanatory, but these are explaining what we want to include or exclude from that index policy, and meaning, are we going to, you can think of it that way, that are we including a certain path in that tree that it is creating, that kind of visual that we were looking at before. That's one way to think about it. So of course, the include value is then, of course, telling which paths we want to have there, and the exclude is telling what we want to have out of the index. And as we were looking at the default policy, you could see that the one value that was left out of there was the e-tag value with the underscore in front. So again, if you haven't followed the previous sessions, a reminder that that is one of those values that is managed by Cosmos DB itself behind the scenes. It is not something that we kind of manually update ourselves as we are working with Cosmos DB. It is more for checking, for example, for consistency and so forth.
Absolutely, yeah. And there are some primary operators, again, which help you utilize the property paths, like the question mark, the curly brackets operator, the square brackets operator, and the asterisk operator. I think they're kind of self-explanatory, again, because you do see them utilized in other scripting languages, in other database or data engine languages, technologies. The question mark operator, for instance, indicates that the path terminates with a string or a number, a scalar value. The square brackets indicates that this path would include an array inside, like tags array we saw previously, and therefore avoids having to specify an array index value. And the asterisk operator is a wildcard that matches any element beyond the current path that you're looking at. And when I say path, I'm referring to like the property of the root document, which can represent an object, might have its own property itself, right? So a path would be the property of the property of the property, and so on, depending on how many objects you have embedded. So here we have one of those examples where, again, we're looking at the JSON document on the left side, and we see that we have a AGL Turing frame yellow 46, and we have a category for it, and the category itself has an identifier and a name. So this is already an object, right? It's no longer a scalar. And then we have some metadata, which is also an object because it has a property rather than having a scalar value. And then we have the price, which is a scalar value, and tags, which is an array, right? So if we're looking at the path expressions here, we could have slash asterisk, which refers to all the properties. Name question mark represents effectively the scalar value of the name property. Category asterisk refers to all the properties under the category property. And metadata slash skew slash question mark will be the scalar value of the metadata skew property. Whereas within the tags array, the scalar values of all possible name properties could be referred to as tags slash square brackets slash name slash question mark. They can be tricky, in all fairness. Sometimes you don't exactly know why an index that you have defined doesn't work in the Azure portal. And at that point, you just got to go back to the drawing board and just figure out where exactly in the syntax did you forget an asterisk or a question mark or a trailing slash. Because sometimes I honestly do that. Sometimes I just want to include name and I just type in slash name and I hit save and surprise, this is incorrect. And I'm looking at it like, why would it be incorrect? Yeah, exactly.
Yeah.
Good.
And I would say, good work on reading all those.
I'm doing my best here. Let's also quickly review maybe, Heini, the indexing policy strategy.
Yes.
Or
let's do
strategies,
that.
should I say plural?
Yeah. So really, if you think about it, when we create that indexing policy, yes, we have the indexing mode that we defined, but of course it is none or consistent. And if we go with consistent, then we need to have the included and excluded path as well there. And so these are the two main things that we need to determine. And for example, in this sample that is here, we have first the included path that has category /name /question mark. So that pulls the actual string value from the name property. And then we are actually excluding everything else from under the category in this case, because we have the category and then the asterisk.
Mm-hmm. So indexing policies must include the root path and all the possible values. Again, you could refer to this one as the asterisk and then so /asterisk as either included or excluded. But obviously you can get up to customizations, and a bunch of customizations exist as the level of precision beyond that base is necessary, which means that you kind of have two fundamental indexing strategies. And we'll see this in some examples that I guess you will show us in a bit. But long story short, you can have some indexing policies which include all the possible properties in the root path and use the excluded path just to exclude specific properties or paths as it is appropriate. This strategy is the case for the default indexing policy. And what follows here is an example of just that, which includes all the properties except for the category.id or category or the ID property of the object, which is within the category property of the document. But the whole general the general rule of thumb, because there has been a bit of a debate on Stack Overflow a while ago, is that it's actually better to include all the paths by default and only exclude certain paths from the index. And with this strategy, you can actually modify your schema and the index will still work with the new set of properties that you might potentially at some point in time in the future add to your container.
Yeah, that sounds like a really good approach, because then it's not like a situation that you forget to add whatever you added in your properties and you forget to add it in your indexing policy as well.
Yeah, absolutely. Now, the other approach that I was telling you about, and in all fairness, I'm not fond of this one, and I'm going to explain later on today why, is to actually choose to exclude all the possible properties in the root path and then selectively include some properties of the paths. And this example that you see here is doing just that. It excludes all the properties, and it explicitly chose to include the name and the tags array name properties within, the name properties within the objects within the tags array. And it's doable, it works, but it is going to present some challenges, and I'm going to talk about them later on today. You know what Linus Torvalds at some point said?
Yeah.
Enough talking, show me the code.
Oh, is that where we're at? Oh no.
I think we're at that point right now.
All right, let's get to it. I just realized I have this failure out here again, but all right, it's back. When I was preparing for this part for today, what happened was that I got a failed Cosmos-db. It wasn't quite fully ready, I would say.
I must say I've seen those sometimes, even in production, when you're ready to do a demo to a customer. And they always say, you must sacrifice a virtual machine in production to the demo gods prior to doing a demo.
I should have done that. I, again, did not do that. All right, so in today's exercise, what we're also going to be looking at is indexes. Surprise, surprise. And we're actually going to use a kind of a neat tool that we have available. And I have actually already installed that. So you can install this tool. It's called CosmicWorks for yourself. And then you can use that tool to input data into your Cosmos database that you have in Azure. So pretty much this will allow you to get some data in fast that you might want to run against your testing environment, for example. And I'm going to do that just because then we will actually have something to play with. and not an empty database. So what I've done, as a kind of a recap, you need your Cosmos database endpoint, as you can see there, and then you're going to need your key as well. Those are the two items that we're going to need, which seems to be the case most of the time when we're working with Cosmos-db. And it is done. So it doesn't take long at all with this data sets. It's not super huge or anything like that. So it's quite a fast task. And other than that, we're not actually going to be needing Visual Studio Code for today, but might be needing it in some of the exercises in the later modules. So I have already navigated to this Cosmos-db, and we can kind of just take a look like what just got tossed in here, because actually I even don't have any idea. So let's check it out. We can see that we have our products container and we have some items in here. And let's see, I'll try to make it a little more readable for you here. So if we just choose one item, we can see, yes, we're actually working with a similar kind of data as we had in the examples in the slides today. So it's kind of at least familiar type of data for us. And so as you can see, there's actually this select statement already here. And we can now edit this if we would like to. And we can pretty much query with anything we want. But let's just do, it also gives you some samples that you could do, but let's grab the name. And there should be a value like this, a headset. So let's just run that by that filter. And we can see here that we have one item that has that particular name. And we can see this is what we got out. So I'm trying to, oh, here we go. Never mind. Why am I not seeing now? Alex, help me out. Where do I find the query stats again? Why can't I see them?
Wait, what? Where are they? You're kidding me. Can you expand the yellow section at the bottom? There's like a chevron. What? Is this like a new UI?
Let's try it this way.
Just
kind of the full. It might be that the default view is no longer showing that.
No,
so let's.
I'm pretty sure it is not.
Execute the query. And now we see the results. Now it's looking as I was expecting it to look like. And here are the query stats. So doesn't actually show me much here. There it is. That's it. Somehow it's not showing very well on my screen today, fortunately. So
I do see you have a bunch of scroll bars nested within.
Yeah, exactly. It's a little weird, but if we scroll very carefully, we can see the request charge. So this particular query took up 2.83 request units in this case. And then it just showed one result and got one document. And this is the document size. So you can kind of see a few things here. For example, also the index hit document count. So how many documents it found from the index and how long did it take to look up the index itself, and so forth. So there are a few things here, but those are the main things for our topic today. And I seriously don't know how to use this screen anymore on this big screen that I have here. I'm sorry about that. Bear with me.
We're sorry that you have a 5K display.
Exactly. All right. So this is where we can also do more queries. If you want to play around with the data set, you can just make up your own queries and check what you can find. And so let's kind of go back a little bit. I need to click completely out before I'm able to figure out where I am here. And let's just get back to our container here, the products container. And then if we look at the scale and settings portion here, this is actually some place where we can find the scale. So how many RUs are put in place. We can find settings like time to live and so forth. And then we have the indexing policy here.
Mm-hmm.
So this is something that we can actually edit. I can click right in here and I can edit it. But if we look at the default one, we can see it has this path that includes all the paths, and then it has this exclude path of the E tag itself in there as well. So that is what it contains there. And so let's just kind of change how we're going to do this indexing policy. And let's put it in there. And in this case, we're going to actually do so that we have the other approach to indexes. So we have the exclude path that includes everything. And then we only include the price value or the value of the price portion in there. So this will be quite different. And we will see the changes of that save. That's what we need to click to get it to go through. All right, so let's wait for a moment. And we're just then in a moment going to run the same query again that we just ran previously. And we can see then that is there any difference in how this performs. So let's put that in there and execute the query. It looked pretty fast this time as well. Let's then look at the query stats here. And this time, we spent 8.09 RUs. So why is it taking up so much more here? Think about it. Alex, would you have an explanation for us?
And that's a good question. I mean, the first thing I would do, because I'm human, I would click the execute button a couple more times just to make sure.
Let's do that. Good point. That's what we all want to do.
We all want to do that. And it's the same value again. It's still the same value.
One more time.
But jokes aside, what is actually an RU, especially for those people who are new here? Let's maybe explain that for a second. An RU is like the horsepower, as I like to call it. It's like the analogy of the horsepower, as in how fast, how performant is your container, your workload. You can share this horsepower with multiple containers at once. And what we effectively denominate with the RU is the IO and CPU capacity of your account for a single kilobyte document being sent and queried over your data. But the RU is going to be used whilst you're inserting data, whilst you're querying data, as well as whilst you're updating the index, which is also an interesting thing there. So enlighten us. Why did we have 8 RUs rather than 2 point something?
Yeah, so if we paid attention to how we changed our indexing policy, so if we look at our indexing policy right now, and we take a look at this, we now have, so that we have everything on the exclude path, and the only path that is in the index is the price. So really, of course, now the name is actually no longer in that index. So it will go through every single document that is in this database now. So that is why we see the difference.
Spot on. I mean, that increase, 4 times increase that we're seeing could be regarded as a table scan, which we'll know is super bad in the SQL world. Because over here, we no longer have the inverted table to determine where exactly our documents are at. So we have to go through all the documents that we have. And how large is your container? A few thousand documents, as far as I remember, Cosmic works.
Yeah, that's about it.
And we have to go through them all. And because it's not that large, we're only going to have a single partition to begin with, and like a physical partition. And once we go through all of them, we determine, hey, do we have that property? Yes, we do. Does it have that value? No, it doesn't. Well, okay, skip it. And we do
Next
this.
one.
Yeah, next one. And we do this one. We do this process for every single document that we have in our container. So it is tricky to say the least.
Yes, I completely agree. And of course, what I'm thinking of now is that, well, what if we, for example, search for price now, since that is in our indexing policy? So let's take a sample with searching for the price. And we're saying larger than 3,000 in this case. And let's look at the query stats. And it's much less than 9 RUs. It's 3.27.
Yeah.
We don't now have the baseline of what it would be without an index. But we can see that since we have the index for the price path, it definitely also gives a benefit now that we're searching by the price.
Absolutely. And in all fairness, this close to what it previously was when you had an equality comparison in the predicate, which was 2.89 RUs or something like that. I would have to watch the recording. It's not the same value, but it's close to that. And again, this is not an equality comparison here. It's like greater than. So a bit more extra work for the engine is required.
Yeah, exactly. And you can definitely, when you're going through these exercises, play around a bit and test different queries, see how much RUs each takes, and test different indexing policies. But now you have the tools to do that, and just edit the index policy and check how the queries run after that. But that's it.
I do want to do a call out to Vernon, because Vernon Tassi actually asked a fantastic question, which goes along the lines, if you have in a query multiple predicates, I mean, what he refers to that is a where filter, and then you have ands or ors in between them, or maybe you have an order by, and then you are specifying multiple properties there, and you have already specified all of these properties in your paths. How does CosmosDB know which index to use? Again, it's a single index, so it's always going to be the same index, but rather, how does it know on which leaf to go to determine what documents are matching the query?
That is actually a really good question.
It is.
It is. I haven't thought about it that much, I have to say.
Well,
have you?
I did have some time while we were doing.
Oh, good.
There.
Thanks for putting me on the spot.
In order to answer his question, I think it's good to go back to the slide deck, because there are some intricacies, let's say, on how indexes work and how you utilize these indexes. And before the answer is fully answered, maybe let's present this. So in CosmosDB, there's really 3 types of indexes that you can have. The included path, which sometimes we call the range index, the spatial index, and then the composite index, which we haven't touched base on at all at this point, right? So let's maybe talk about that as well. For most of the queries, a range index is just perfectly adequate. These would be fantastic for equality filters, for range filters, like the one you had previously, where price is larger than 3,000, or maybe price is less than whatever. Most system functions in the order by clause. Again, in most of these cases, the range index is just spot on. It's more than enough. You don't need anything else. But of course, if you're running a spatial system function in CosmosDB where you have spatial indexes, where you have spatial data, spatial indexes are going to be great for that. And they can really improve the performance overall. And in some cases in which, let's suppose you have a complex filter or an expression, or maybe even an aggregate that has an order by in a filter, right? You can use a composite index to take your query performance one step further, one step up. And one thing to bear in mind is that the indexing metrics are going to be primarily aimed at helping customers become better at utilizing the composite indexes for optimizing the reports. I'm going to touch base on that one in a bit. But long story short, when you start a new CosmosDB container, as we all know, you get to that darn default, that ugly looking default, where you have a range index on all the properties. So in other words, you start with a /* index, which includes everything, meaning that Microsoft just gone and indexed everything in a single every single property for you by default. And it pretty much looks like this, like you have presented it previously. You head over to your This is, by the way, I think this is a better resolution than the one you had, which was just massive. I do appreciate, because my eyesight is not that good. So over here, I would have to use a magnifier. But nonetheless, people would normally go to the Data Explorer section, open up the container settings and scale and settings rather. Mm-hmm. And once they've done so, they would see the indexing policy that they would work with, right? So how do we know where and why? I sometimes get this question: why does Microsoft even exclude eTag to begin with?
Yeah, I don't think it would make any benefit to include it at all.
Absolutely not. Absolutely not. I mean, some people who have watched this series, this is what, the 9th episode, I guess, or maybe the 10th. Mm-hmm. Some people might remember that at some point we talked about optimistic concurrency. eTag is specifically utilized for optimistic concurrency. The whole purpose of eTag is effectively to understand that if you have multiple consumers all handling the same data, and well, you don't have transactions, you want to update something, you want to ensure that whatever you're updating has not been updated already in the meantime, you're going to update with a option where you're saying that we need to match the eTag. So when I query the information, I store the eTag on the client side, on my internal memory maybe, and then once I have the eTag and I applied whatever change to the document, I'm ready to push the update back. I'm also going to provide the eTag, which effectively is the client saying, hey, this was the last value I was aware of when I applied whatever update. And the engine looks at it and is like, no way, the document already updated. You got to go back. You got to query it one more time, right? That's optimistic concurrency. So the thing with eTag is that this is a built-in system property. Like every other underscore system property, they're all built in. What this means is that whatever update you do, whatever create, whatever delete, whatever operation you do on a document, the eTag changes. So because every single operation on a document changes the eTag, that would enforce the index to always update. Yeah. And effectively, well, update the leaves and so on. And this would be counterintuitive for two reasons. Number one, I don't expect anyone to ever write something along the lines of update something where eTag equals, because, well, that's not even good for anything, right? You don't query things by eTag. And on second basis, you won't even order by the eTag. So you can just flush it out automatically. I would argue that sometimes you could use the timestamp for the same purpose as well. But sometimes timestamps are useful for ordering. We can talk about that maybe later on. But long story short, as we look at these, actually, let me get rid of these animations here. This eTag property is just used for this for a reason, which is a separate reason for the rest of the data in Cosmos DB, right? And in the case of eTag, it's optimistic concurrency. And if you're building an application with just many updates of the same documents, eTags are going to be very important for building those sorts of access patterns. But on the premise that you're doing a lot of updates, the last thing you want is waste RU on a property which you're never going to query against, because you're not going to use it on a filter. Plus, every mutation is going to generate a new eTag, right? So then you would re-index the data again, like literally every update, every create, every delete.
Yeah, and if you had a query for it, then it would be wrong the next time when that got updated. So
yeah. Now, I think this is good food for thought. Unfortunately, this eTag, even though it's good to be there, it just makes the default index policy look ugly. Honestly,
it does.
It also looks bad because it has to be escaped. I never fully understood the reason for why they have to escape. Like the eTag property doesn't contain double quotes. I at some point asked this on Stack Overflow. Nobody really knew the answer, so maybe a developer at Cosmos DB could have given us the answer. I honestly don't know. In no fairness, it has to be escaped. I've seen this in the docs. You literally seen it in the portal as well.
Yep.
But other than that,
no idea.
you know this document that I have here on the top right hand side of my slide deck. This depicts a fictional container that would hold some employee information. And a more specific use case here, we have a document representing Mr. Mark Brown, who lives on 123 Cosmos Road, works for Microsoft and is a product manager. Of course, we're giggling here because we do say hi to Mark, who is the principal program manager for Cosmos-DB. So with the default indexing policy, every single property will be indexed. We will index the name, we'll index the address, we'll index the company, we'll index the job. We'll also index some of the system properties as well. RID, self, ETag, attachments, TS. I mean, ETag not, because by default that's going to be excluded. But we obviously do include the ID value and the timestamp value as well. And this happens even if you haven't defined explicitly an index on these properties, right? So you want to be mindful about that. So if we are to go and optimize this index policy to only include the necessary paths, we're going to have, for instance, the name and the address properties included on the premise that we know that all our queries are only running executions against the name and the address. And additionally, we opted to exclude every other property. This would be a good use case right here. So for this particular document, this would effectively translate to indexing the identifier, the name, the address, and excluding everything else, including the company, the job, and the system properties. Heini, you might ask, why do you even do this?
Why would you?
Do you know the answer?
No, I don't know what's on your mind. I was thinking about...
I know you're ready to speculate.
Well, I think if you had just like you knew that you are only going to query by the name and so forth, then you would it would be the attempt to optimize to have just that part indexed. And so when you're doing updates and so forth, it is only needing to update those two specific values and nothing else.
That's spot on. I couldn't have said it any better. But I do want to emphasize for the audience that this optimization that you have mentioned here is all about the write. So
yes, exactly.
The fact that I am a bit more specific in the way that I index my policy does not increase the performance or either the latency, of course, of my reads, right? I'm optimizing the write. Because whenever I'm writing some data or updating some data, which would only apply an update to the job or to the company, I do not enforce an index update to occur. And therefore, my write would consume less RUs. So specifically, by not indexing information that I'm not going to filter against, I'm just saving a bunch of RUs at the write time, not at the read time. So this optimization won't necessarily increase the performance, as in you do a query, you select something. It won't make the query run faster, for sure. But it will make it cheaper to go and write and even update different documents.
Yeah.
So that's pretty cool, in my opinion, at least.
Yeah. And the one thing to highlight here was also that the ID always gets indexed, whether you include it in the path or not. Yeah,
absolutely. I think that's spot on. Good point. Now, and these are just some additional animations where we're seeing what exactly we took out of the document. Now, here is another fictional scenario. Imagine we have this approach where we decided to implicitly include the path and exclude everything else. And now we have added a new property, right? We added the property called age. Within the indexing policy, because of the way we have defined it, age would not start, would not be indexed because we opted to put the / on the excluded path. And this implies that the age property, which is added in the document, is not going to be there, right? It's not going to be indexed. So basically, we're still indexing the identifier, the name, and the address, but we're excluding every other property. Or simply put, when you explicitly include some properties but leave everything out, any net new property will not be indexed. So sometimes this is the intended behavior, but sometimes, in all fairness, most of the times it is not. So another option is to just flip the way you define the policy. So just pay attention to the left side of the policy. You see what I did there? It's flipped now. What I mean by that...
The top went to the bottom.
Exactly. So I'm explicitly excluding the company and the job, but I'm including everything else. So you specify that you want to include everything except for specific properties that you're specifying. When I talk to customers, they usually ask me if they should by default include or by default exclude. And I think there has been a lot of debate. I have definitely seen a lot of debate on Stack Overflow as to what the right answer is. And in all fairness, as a consultant, you always answer it.
I often go with this second approach, I have to say, like personally.
You go with the second approach? Yeah, I usually go with it depends.
Well, that's true. It does depend. That's
depend.
true. It does.
I personally fancy the approach of including everything by default, because if you add a new property, you then have to explicitly go and add it to the index policy and rebuild the index unless you have included everything by default. And here's another thing. If you add a property and start querying it and then wonder why those queries don't work or why do they end up taking so long, you just have unintended consequences. Right? So instead, if you include everything by default and exclude specific things out, you're kind of future-proofing your data model. And I literally, in my own company, I've had cases where we write an application, we take it out to production, the data set is rather small at the beginning, within a few months it's large, and then we reconsider our data model and we start adding new properties and create new partitions with new models and whatnot. If you ever do that, explicitly including and implicit or explicitly excluding everything is going to be your worst nightmare, because it can take up to days to rebuild the index. It's horrible. So one of the key takeaways is to remember that you're not optimizing your query performance. Specifically, you're not making your query faster by being more specific with the properties that you're including. And that's why I'm saying include everything, exclude whatever you're sure you won't ever need. And actually, there's another interesting thing with Cosmos-db. If you add a new property, especially if you're coming from the relational world of SQL, you might expect that adding the property enforces the index to rebuild. Well, in Cosmos-db, it does not. Well, adding a property does not enforce the index to automatically rebuild itself. That's because Cosmos-db uses this concept of the inverted tree to save the index, so it effectively adds leaves to the tree that always get added part of the index, which again is performance. So I know how Microsoft sometimes says indexes, plural, but that's a lie. It's a single index. It's a single inverted tree. It's just so that my customers and your customers, Heini, they mentally understand the concept of an index, because, well, plural makes more sense in that sense. I think there's a lot to say when it comes to indexes. I'm actually gonna type in here for our people, for our producers, a link that I find super useful, which is the overview of indexing. And if people are interested in learning more about indexes, they should head over to this URL, aka.ms/cosmosdb-indexing, and this is going to take them to the indexing overview page on Microsoft Microsoft Docs. Really useful stuff there. So in continuation, I actually have a few interesting queries where composite indexes are going to be utilized. And composite indexes is a very interesting topic, Heini. Maybe you want to introduce this one yourself.
Yeah, so pretty much this is now the topic that will answer the question that came in earlier. And this is for those situations where you are actually combining different properties in your query and really want to get the best performance for those and building the index in the right way to optimize for those situations.
And one thing to point out is that these indexes are going to be utilized not only for the predicates, so not only for the where clauses, but as well as for the ordering. So let's say you have this query that you see here on the right at the top, in the corner of the slide, which filters by name and then orders by age in descending order. This query is going to work. They always work. It's even going to work with the default indexing policy. And it will. And this kind of answers the question that we have had previously. But even with a custom one, even with a custom index, like the one you see on the slide deck, this query will work. But you will observe that the amount of data, if it increases over time, particularly if the amount of people called Mark would increase over time, the RU charge of this query would increase quite a bit. And when I say quite a bit, I mean like a lot.
A lot.
So yeah, if you have a lot of data, by that I even mean up to terabytes of data, this query might even cost thousands of RUs. So the solution for that, and the reason for that is that Cosmos-db has to calculate which query, which path works better, and then it would use the same index multiple times just to determine the data and just create a union. It's just chaotic, right? So if you create a composite index, the solution actually saves most of those thousands of RUs, really, because what's going to happen is that there's going to be a leaf, effectively, which contains the combination of both the name and the age, because that would be what I would put in my composite index, just like here. So for this particular query, I would create a composite index on the name and the age, and I would specify the name in ascending order and the age in descending order. And if you have this composite index used in your query, you'll see the RU charge drop dramatically. In this particular use case, the query engine is able to use the composite index and therefore evaluate the filter and evaluate the order in which it makes a lot of the more efficient utilization of the index in this case. Again, it's all about being more efficient. And in this case, it's all about using less RUs during your reads. I'm just going to have to go through these quickly, probably, especially in the interest of time. But similarly, if you have a query that averaged, look at the average age among all employees at Microsoft, this would be another great instance for a composite index, because we have a filter and an aggregate, and together what we can do is, in this case, create a composite index on the company and the age. And again, ascending, descending order is something that you would have to specify. One thing to bear in mind is that if you explicitly use descending for an ordered by, for instance, your composite index has to match that, because otherwise it will not be utilized. Here's the third example. If you have a query that filtered on name and then filtered on the identifier, you could create an index to filter on the name and the identifier to pretty much improve the query performance. I think there's a lot of things to learn here. If I would emphasize, or if I would want to take something away, is that composite indexes, we're not talking about something which is required, but something which tends to improve the query performance when you're operating at medium or large scale. The general rule is that the more data you have, as well as the higher cardinality properties you have, the more impactful a composite index is going to be. So if the ID property has a low cardinality, which I know is just ridiculous, this composite index will not help much. It will definitely offer some improvement, but it's not going to be like a night and day or a huge difference whatsoever. ID, of course, tends to be a property with high cardinality typically. So you typically see pretty much a good improvement there. In all fairness, on this slide, for instance, we have had the ID in ascending order. And one might argue, when are you ever going to use that as as a filter where you're saying ID greater than? In most cases, you probably are not. But because you're using GUIDs, I guess. But if you do use integers, and then you're looking at your identifier as the unique identifier of something like the receipt that you're creating per day, and you're only interested in whatever receipts were issued at the second half of the day, you could say greater than 1,000 on the premise that 1,000 was the ID at noon, for instance, right? It's a bit far-fetched, I'll give you that, but hopefully the concept sinks in a bit.
Exactly. Yeah, I find the composite indexes really interesting on how you can then kind of put together two of those values and have them added to that inverse tree as well. So a lot kind of expands the capabilities of optimizing those queries where it's needed.
Yeah, I think this indexing capabilities and this indexing technology overall is easy to understand at the beginning, but the more you delve into it, the more complex it seems. Right? Exactly. And even though this is an introductory topic on indexes, we're barely scratching the surface here. The next episode is actually gonna cover indexes as well. The idea is that when you change that indexing policy, going beyond the syntax and the special characters and whatnot, it's pretty much hard, if not even impossible, however, to break things. That's the good news.
Yeah, it is.
As a developer, you want to optimize things. You want to optimize the indexing policy. You're not going to break stuff. So you're good. You're in good hands.
That's a positive thing.
Unless the indexing policy has some sort of a problem that you wrote out and your syntax is incorrect. But what I'm trying to say here is that when you change your policy in Cosmos DB, there's literally no impact on either the read or the write performance. So if I had like a default index policy and I decided that instead of /* include everything, I want to /* exclude everything, and I want to instead just the index just to index the name in the include property. By saving that change, whether I do it in the portal or the API, doesn't matter, I'm going to enforce the Cosmos DB engine to do stuff. But here's the deal. My availability and my performance will not be impacted, because Cosmos-db does not use the index while it's being transformed. It uses whatever was previously set as the index, as the inverted tree.
Yeah.
And when the index policy is fully transformed, then it uses the new inverted tree, if there is one, right? So if I had the query that would use the name property, the performance would have been impacted while the index's policy transformation is occurring. And I think that's a very important aspect.
Yeah, it's good to know, definitely.
Yeah. Any other things that we may want to talk about tracking the index progress, maybe, Heini?
Maybe let's go for it.
Let's go for it. Another thing that comes to mind right now to me is that if you're adding properties to an index policy, it obviously takes time for the index to catch up, right? Again, the good thing here is that the engine doesn't use the index until the changes are actually applied to the policy and they're fully complete. So there's no chance of getting ever any inconsistent result, any stale records, any missing results. One way to think of changing the index policies is that these are very easy to change for developers, even when the data is in production. And additionally, it's also good to know that indexing changes, when they occur, they consume RUs, but they only ever consume actually the leftover RUs. This is something that people don't realize. So, Heini, how large was your RU in the container that you created previously? Was it the default 400?
Yes, it was just the default, I believe.
So out of those 400, let's just imagine that you run your database operations, regular DB operations, and they consume supposedly 200 on average, 200 RUs on average. What this means is that even if you have terabytes of data, if you ever apply an index update, it's not ever going to use more than the leftover 200 RUs.
Yeah.
Or let's take another example. You may set it to double, 800 RUs. If your overall typical regular database operations consume roughly 800 RUs, just about, right? Then we're going to be left with a few RUs, 5, 10, 15, who knows, to do the index update. And here is where it gets tricky. Because if you do have that, it may end up taking days for the index to be updated. So you're not really troubleshooting or debugging anything really as a developer.
Yeah.
So again, like I always say, planning is key. You need to plan these things. And there are two ways in which I tell my customers to go about the index updates. One of them, as I'm sure you would speculate, if you have 800 RUs, you consume that, want to do an index update, what do you do? What do you say, Heini?
Going blank here. Go ahead.
You're going
Tell
blank?
me.
Just temporarily increase the RU.
Oh, yeah, of course.
You can always do that. It's the cloud. What goes up must go down, but you can always move it elastically, right? So if you want to update the RU and you have gigabytes or terabytes even of data, what you can do is just increase that temporarily to 1,000, 2,000, you name it. And then once the index has been fully updated and you can track the progress, you can come back with the number and you're good to run your database with the new index. Another approach, and this is, I've literally seen customers in production make this mistake, is that they want to explicitly exclude or explicitly include new properties. And what they do is that they add the property, they hit save. They add another property, they hit save. They add another property, they hit save. Every time they hit save, they enforce the index to be updated. And it can take minutes, tens of minutes, hours, days. You don't want to do that. Do the entire change at once, click save once, batch the changes, and you're good.
Yeah, exactly.
Now, here's a hidden gem. A lot of people don't know about this. This is going to be, I guess, our Mr. or Mrs. Congeniality of our show today, indexing metrics. Have you ever used them?
I have used them a little bit. I actually don't think I've used them to the extent that I should have, but I know other people have used them more and are very happy with them. So
yeah, indexing metrics actually have 4 properties. So 4 major properties that should be utilized. One of them is called utilized single indexes. And hopefully this will give the full answer now to the question that we have had previously. Potential single indexes, utilized composite indexes, and potential, in other words, recommended composite indexes. So the whole idea to this is that you can see if an index is utilized, and with that evidence, you know that the query engine is using that index path. So in other words, the paths that the query engine needs are going to be returned to you. And it's not something that you need to verify. It's not something that you need to test. And the other metric here is the more important one is the ones that show potential. You should think of this as kind of an educated guess, something that is calculated. There's no certainty that if you use those paths, the query engine will even use them, or that you would dramatically improve the performance. But there is some internal heuristic at Microsoft, which they utilize, that makes them believe that the recommendation from the engine is reasonable, and therefore the engine will be reasonably confident by adding those indexes, it will actually improve supposedly the query performance. Most of the times it does not hurt. Most of the times it works as expected. Sometimes it cannot work. But the goal here is to use these metrics to easily and better understand the composite indexes that should be utilized. So the main goal is literally this. Microsoft also noticed a lot of feedback from developers actually using Cosmos DB that composite indexes are awesome for optimizing query performance when you know how to use them, right?
Yeah.
Know how to use them is the emphasis here, because unfortunately, figuring out when to use them or how to use them is oftentimes a bigger learning curve than it may be worth in some cases to even implement them in the first place. So especially when you're at small scale, you won't see a major impact. You don't even think you need them. And unfortunately, the need for a composite index doesn't really come up until you're very late in the development stages or you're even in production already. So it's, I guess my take to it, Heini, is that it's usually when the data set is large enough that a composite index becomes a little more essential. And I do use a lot of mock data just to try to emphasize the importance of a composite index in the early development stages. And hopefully they usually sink in and people make more sense out of them. And if you also wanted to make it easier to discover properties that you have forgotten to index, you also have that metric that you could use these for. I do have here a bunch of use cases and what to avoid and what not to avoid and how to use them and so on and so forth. I think the key takeaway, I'm just going to put it right there, is that the purpose of using these indexes is not to replace the diagnostic logs, quite the opposite. The way I use them is that I'm looking at which is the most expensive query through diagnostic logs. And then once I have that query, I run it myself, I enable the metrics, and the metrics tell me which indexes or which paths rather are we using and which potential paths could help your query improve. So that's the way you should use them. And I know this is easier said than done because, Heini, how many times were you told to create an optimization on a query and you never saw or wrote the query? I mean,
quite often.
Quite often, right? You need to know the query before you can do any optimization.
Yeah, exactly.
As developers, we don't know the queries. So that's the big selling point here. Know your data, know your queries, and then you can write your indexes. And after you did that, check if the expectation, which is the engine is using those indexes, actually happens or not through the metrics. And then you know if they're utilized correctly, and even more importantly, you'll know if they can be improved with the potential metrics there. And the way you enable them, if you are using C#, there is going to be a request option where you're saying populate index metrics, and what this returns is just additional data on those 4 different properties that I was telling you about previously. I'm not seeing any additional questions, but we do have some questions here as a knowledge check. Want to go through them?
Yeah, let's go to them. Perfect. I think this last part was really good about really clarifying how can we verify that these indexes really work.
Yeah.
All right.
Thank you.
Question number 1. So you have created a bulk operation in azure-cosmos-db SQL API that will insert hundreds of thousands of items into a container, a huge amount. You need to temporarily disable indexing and re-enable it after the bulk operation is complete. Prior to starting the bulk operation, which indexing mode should you configure in the indexing policy? Is it A, none, B, consistent, C, automatic?
Interesting question. So I think I don't remember. I know there were 2. I don't remember seeing automatic among them. So I would rule that one out.
Yes, me too.
And it says that we need to disable indexing, do the bulk operation, and then we want to bring it back in. And I do remember vividly that I've mentioned at some point that when you do bulk operations, it's the only good use case for disabling the index by using a particular policy. So I don't know about you, but I would vote for A.
Yes, me too. We need to be careful with the wording here. It's asking prior to starting the bulk operation. So before we start the bulk operation, we put it to none. And then after the bulk operation, we would return it to consistent.
Which is the default one that we have seen
Exactly.
in the default policy. This is a long question. People can be tricked. And I don't know about the 420 exam, but other exams do have these a lot of wording questions. And in all fairness, you're looking for the things that are mostly familiar. Consistent is indeed the default policy. You see that in the default in the policy index as well, or indexing policy. But the wording here says how do you disable it before you do the bulk operation. Want to take the second question as well?
All right. So question number 2. So you are authoring a new indexing policy for a container in azure-cosmos-db SQL API. You would like to define an included path that includes all possible properties from the root of any JSON document. Which path expression should you use? Should we use the asterisks, the square brackets, or the question mark?
So the question mark was the one that we have utilized for matching the single literal, right?
Yes, exactly.
Means that if we have objects in our properties, it's not going to match that. The square brackets was utilized for matching anything that was an array. Again, that would not match either literals or objects, which are not arrays. So I think we're left off with option number. You say it.
A. We want A.
It is A, and actually most of our audience apparently is going with A as well. So kudos from that. Wonderful. So that being said, I think this was a fantastic day today. I don't know about you, but I've definitely learned a lot. Again, we have learned about creating and executing SQL queries, as well as projecting query results, and last but not least, using some built-in functions in a query. How did you feel today, Heini?
Today was really exciting. I'm a little tired, but it got me all pumped up about it again. So it will be interesting then trying to get to bed after this. I think it was really fun. How about you, Alex?
I've definitely had a lot of fun. I do feel like I've monopolized the conversation a bit, and my apologies for that, Heini.
No worries.
I did warn you in advance that this is one of my favorite topics.
Yeah, and I knew you had some good stuff coming in there, so I think it was perfect.
Appreciate it. If people do want to learn more, besides the fact that they can reach out to you and myself as well over Twitter, they should also scan this QR code or head over to aka.ms/learn-live-azure-cosmos-db-index-policy. That's a long URL. I thought aka.ms was all about shortening the URLs, but this one feels like impossibly long. Nonetheless, it's easy to type in because people will remember both Learn Live, Azure, Cosmos DB, Index Policy. So again, today we have covered a Microsoft Learn module, which I'm very fond of, define an index in Azure Cosmos DB SQL API. People can get their hands dirty at their own pace. And I do want to shout out and emphasize the fact that you don't need to pay anything. You don't need an Azure subscription, even if you're fond of Cosmos, if you want to learn more about Cosmos. Just make sure that you sign up for a Microsoft account if you don't already have one. If you're using Windows 10 or Windows 11, there's a high chance that you have set one up when you have set up Windows. That's your Microsoft account. You can use it. You can learn. You can get experience points. You can get over your learning path with Cosmos DB. And then, I guess, tick a bunch of gamification checkboxes and whatnot.
That's always important.
It is. It is.
Yeah, and then next week, there is then going to be another session on indexes, and this time it's going to be about customizing indexes in Azure Cosmos DB SQL API. So another really interesting topic coming up.
Especially for me, because I'm so fond of them.
Yeah, exactly. And you're going to be there next week, right?
I will be there next week.
Perfect.
Will you as well?
No, not me this time. I'll probably join the stream, actually, but as an audience this time.
Oh, so I will only miss you from seeing seeing you on the camera.
Yeah. I know
Good.
you'll do great anyways. All right.
Appreciate it. I do want to give a big shout out again for people at Microsoft for creating the certification, and remember or remind everyone to take the exam, especially now it's in beta. They get the discount of, what is it, 75%?
Yeah, I believe so.
It's definitely worth it. And with 10 episodes, I believe, out of the 15 already in, I'm sure that people haven't learned a lot. And if you haven't watched all the episodes, if you were not live so far, make sure to head over to YouTube, watch the recordings, learn some more stuff, learn tips and tricks. Every single recording, every single show had some additional tips on top of the Microsoft Learn modules. And with that, I think it's time to say our goodbyes.
Agreed. Yeah.
It was great seeing you today, and it was a great topic. And thank you so much for co-hosting this one with me. Heini, Hasan, thank you for your help, and everyone, stay safe.
Thank you, everyone. Have a good day or good night.
Good night.